Okay, so we are going to talk about the last two circumstances that we will encounter. All of the exponent rules we learned still apply. So if I have something where I have a v times a v, I'm going to add those exponents and so on and so forth. The difference is we are now going to throw in this as an exponent and negative numbers as exponents. Okay, so rules. Anything to the 0 power is equal to 1. And unless you want to hear a really long, detailed, confusing explanation, just accept that that's true for now. Okay? If you choose to go study math further, you can find out why. But for right now, anything to the 0 power equals 1. It could be the ugliest thing you've ever seen. That's not that ugly. But if it's to the 0 power, it doesn't matter what that looks like. It's still 1. If I have if that whole thing is to the 0 power, guess what? It equals 1. It doesn't matter how ugly it is. If it's to the 0 power, it equals 1. And that can save you a lot of stuff that may look confusing. If I'm looking in here, I might start getting confused about what to do or thinking that that might be a lot of work. But if I see this, I can be like, oh, I can skip all that work because it's all to the 0 power, which makes it 1. All right? So that's our 0 power, or a power of 0. And then our other thing that we're going to talk about is a negative exponent. Does anyone know what you do with a negative exponent? For example, if I have x to the negative 3rd power, I can never leave a negative exponent in my answer. So how do I make that exponent positive? No, because multiplying by something would change the base, not the exponent. So multiplying by the base doesn't do, or something on the base, doesn't do anything. A lot of people will think, oh, just make it this. Just put the negative down there. That's avoiding the problem. A negative in the exponent is a negative in the exponent. It doesn't just magically change to a negative in the base. What a negative exponent means is you move it to the other side of the fraction to make it positive. Now, I say you move it to the other side of the fraction. Well, that's not a fraction, is it? Yes, everything's technically a fraction. It's just over 1 in this case. So where is that in the fraction? It's on the top. So in order to make it positive, what do I need to do? I need to move it to the bottom. So if I want this to turn into a positive exponent, I need to put the x to the 3rd on the bottom, and now I can say that the exponent is positive. Now, is anything left on top? Nothing's left on top, so I put a 1. If I have something like this, let's say I have xy to the negative 2nd. What am I going to do? I'm going to think about this as being over 1. And what's going to move? The y to the negative 2nd moves to the bottom. The x doesn't have that exponent, does it? It would only have that exponent if it looked like this. Right? But it doesn't. So the x is not going to do anything. The x is just going to stay there on the top. He doesn't have to move. And then the y on the bottom now will have a positive exponent, and that's what my answer would be there. So those are two things that we're going to play around with today, okay? So let's go ahead and turn our paper back over and start working through some of these examples. So this was the first exponent rule we talked about. I have nothing here. Let's see, our coefficient we would assume is 1. And 1 times 2 is 2. And what would I do with these exponents? Add them. What is negative 1 plus 2? 1. How do I write 2v to the 1? Just 2v, right? So even though there was a negative exponent, I don't need to worry about flipping anything until I see if it's still negative at the end. That's when I need to worry about changing stuff. Okay? Number 2, what would I do here? Would I add those exponents? I'm distributing it, aren't I? So that would give me n to the negative 6, because 2 times negative 3 is negative 6. Can I leave my answer like that? No. And it even says so right there. No, I cannot leave my answer like that. So I need to remember that this is over 1. So where does the end of the negative 6 go? Down to the bottom. Now it's a positive 6. There's nothing left on the top, so I put a 1. And that's my answer. Okay. All right, what have I got here? I have a 0 exponent, don't I? So guess what? That whole thing is just 1. So I have 1 times negative 3 to the 3rd power. What is negative 3 to the 3rd? It's negative 3 times negative 3 times negative 3, right? Is that going to be a positive or a negative answer?
Negative.
Negative what?
27.
27. Right? 1 times negative 3 is negative 3. Times negative 3 is positive 9. Times negative 3 is negative 27. And you can obviously go to your calculator there too. All right, number 4. I have a positive coefficient times a negative coefficient. What's that going to give me? 2 times negative, technically that's negative 1, right? So what is 2 times negative 1?
Negative 2.
And what am I going to do with those exponents on the x's? Add them. 3 plus 3 is?
6.
There's my answer. Okay. So? Okay. Number 5. Now there's a couple things going on in number 5. Do you think it would be easiest to go ahead and multiply these things inside first or distribute the exponent first? Let's simplify what's inside so we don't have to distribute to as much. Now how do I know I'm going to distribute? Because inside I have multiplication. Remember I just talked about that, going over that with the homework? If it's multiplication, I will be distributing. If that was a plus, I would have to physically write it however many times and multiply it out. Okay? So let's see. What's negative 2 times positive 2?
Negative 4.
And what's r squared times r squared?
R4.
R to the 4th. And then I have this exponent out here. Now I can distribute it to something that's a little easier. So here's my question. I know that I'm going to have r to the 16th. Yes? Do I have negative 4 to the 4th? Or do I have negative 4 to the 4th? Which one do I have?
Parentheses.
Parentheses, why? Because the negative 4 is completely in these parentheses, right? So it needs to stay with a set of parentheses. Why is that a different thing? What's the difference between negative 4 to the 4th and negative 4 to the 4th? Yes?
It's because when you multiply, the first number is going to be negative, but the rest is going to be positive.
Yes, this one ends up being negative 4 times negative 4 times negative 4 times negative 4, whereas this one is negative 4 times 4 times 4 times 4. The negative just hangs out in front. This answer will be what? Positive. This answer will be negative. Okay, so watch out for that. All right, so let's go to my calculator to figure out what negative 4 to the 4th is. So I'm going to open parentheses, negative 4 to the 4th. I get 256. So my answer here ends up being 256 r to the 16th. Capiche? Good answer. All right, now we get into the fun ones. Love these guys. All right, I have a negative exponent, so that's a problem. So if I were to try and do this the long way like I did on the homework, I would write n on the top, correct? But how do I write negative 2n? I can't. So let's move it first and then think about what it is when we write it all out. So on the top, does that guy need to move to the other side of the fraction?
No.
No, why not?
Because it's
Has a positive exponent, doesn't need to change. Does this guy need to move to the other side of the fraction?
yes.
Yes. So he's on the bottom. Where's he going to move?
To the top.
To the top. Nothing's left on the bottom, so I have to write a 1?
No.
No. So what do I have? I have end of the third and end of the second?
Yes.
Well, there's end of the third. There's end of the second. What do I have?
And
End of the fifth. All on the top. Okay. Let's look at number 7. So looking at my numbers, can the 2 and the 3 simplify?
no.
So I have a 2 on top, a 3 on the bottom. I can't do anything about that. I have an n on the top and an n on the bottom. Which one is not going to move?
The 3.
Not looking at the 2 and the 3. Is the end of the negative second not moving, or is the n not moving?
The n.
Why?
Because the positive 1.
Has a positive 1 as an exponent, right? So he's going to stay on the bottom. What's going to happen to this end of the negative second?
Move to the bottom.
He's got to move to the bottom. So I have an n here from what was already on the bottom, and an n squared now on the bottom. So what does that give me total? I have a 2 on the top, and what do I have on the bottom? 3n, not m, 3n cubed. So? All right, I want you to try, see if you can do 8, 9, 10, and 11. I have faith that you can try 8, 9, 10, and 11. Okay? 12, 13, 14 get a little crazier, but see what you can do with 8, 9, 10, and 11. All right, so what happens here? Talk me through it. They both switch. In what regards? First off, you got to treat the 3's different than the x's. Since they're not in parentheses, what's going to go on with the 3's? They're going to cancel, aren't they? 3 over 3? Okay. Where does this x to the negative third go? To the bottom, and then it becomes x to the positive third. This x to the negative second goes to the top, and it now becomes x to the second. So if I write this out, I have 2 x's on top and 3 on the bottom. So it looks like 1 is left on the bottom, but nothing on top. So what do I have to put on top?
1.
Will I give you credit if you say the answer is x? No, because that is not an x on the bottom. That's an x on the top if you don't put anything. So if it's on the bottom, you do have to put that 1 on top. So? Okay. Let's look at number 9. Does the 2 stay or go?
Stay.
Stay. And there's nothing to cancel it with, right?
No.
Does the b stay on the top or move to the bottom?
Stay on the top.
Okay. Does the 8 to the third stay on the top or move to the bottom?
Move to the bottom.
8 to the third? That's positive. It stays on the top. What about the b to the negative third? That's on the bottom. It's got to move to the top, doesn't it, to become a positive third. So now there's nothing left on the bottom. Do I need to continue writing the bottom? No. So let's see what I've got. I've got 2. I'm going to go ahead and write these in alphabetical order. I have 8 to the third. And what do I have for b's? 1, 2, 3, 4 b's. Right? Because I have 3 and then another one here. So that's what my answer should look like. So? Okay. All right, let's look at this guy. Looking at the coefficients first. There's no coefficient on top, which means it's a 1, correct? There is a coefficient on the bottom, and it's a 3. Can't do anything with that. Doesn't have anything else to cancel out, correct? And I'm going to go ahead and put the 1. I may not need to write it later, but we'll see. X to the negative third, does that stay on the top or move to the bottom? Move to the bottom, and it becomes x to the positive third. Y to the negative 1, stay on the top or move to the bottom? Move to the bottom and becomes y to the positive 1, which just looks like this. The 3 I've already dealt with. What about this x? Stay on the bottom or move to the top? Stay, why? Positive exponent. So I think I do need that 1 on top, don't I? And what do I have on the bottom? I have x to the third and x giving me what?
X to the 4th.
And then y. Done. So? Now, 11 I tried to make harder by doing what? Throwing in a third letter for you. But does that really make it more difficult? No, you're really still just seeing, is it staying or moving? Staying or moving? So let's see. Looking at the coefficients, I have a 3 on the top and no coefficient on the bottom. So I think that 3 is stuck. Can't do anything with it. So let's go next one. C. Stay on the top or move to the bottom? Stay. A to the second, stay or move?
Stay.
B to the negative first, stay or move?
Move.
Okay. C on the bottom, stay or move? Stays on the bottom. B to the negative first, stay on the bottom or move to the top? Move to the top. So let's see, what can I cancel? A B and a C? Yes? So what am I left with? 3a squared on the top. Do I need to put over 1? No, I only need to put the 1 if it's on the top. So? Yes, this looks like a Z, but it's a 2. Sorry. My 2's and my Z's start to look alike. So when I write Z's, you'll notice. Was there one with a Z on here? On the back, was there? You'll notice when I write my Z's, I put the little line through them because otherwise my 2's and my Z's get confusing. So, something I've used to adapt to my handwriting. Okay, let's look at what we've got down here. Or over here, I should say. I've got some stuff that needs to be taken care of on the bottom, don't I? The top is pretty much as simple as I can go. I do know that I'm going to need to do what with it? Move what? The X only, right? Not the 2, but the X to the bottom. I'm not going to do that yet, though, because I want to simplify the bottom first before I put more with it to make it look more complicated. So, I have 2x squared times x to the 0. What do I know about x to the 0?
1.
It's 1. So what's 2x squared times 1? 2x squared, right? And then I have this cubed outside. So doesn't that mean that I really have 2 cubed and x to the what? 6th on the bottom, or in other words, 8x to the 6th? Do you follow that? So, on the bottom, instead of writing this confusing thing, or instead of writing that, I've simplified it all the way down to 8x to the 6th. Yes? On the top, I haven't touched it yet. I have 2x to the negative 4th. Well, now I have a problem just like the ones that you just worked on, 8, 9, 10, and 11. 2 and 8, can that reduce?
Yes.
To what? 1 and 4. So 1, 4. X to the negative 4, stay on top or move to the bottom? Move to the bottom. X to the 6th on the bottom, stay on the bottom or move to the top? Stay on the bottom. So it looks like I'm going to end up with 1 over 4 x to the 10th. I don't know if now is a good time to mention, but I absolutely cannot stand when people use this fraction bar when we're doing problems like this. And let me explain to you why. Because when you have an answer like this, there is absolutely nothing that tells me whether this is 1/4 x to the 10th or whether this is 1 over 4x to the 10th. There is nothing that clarifies that. Why is this a big difference? Because if it's like this, that x to the 10th is actually on the top, not on the bottom. Okay, so please do not use that slash. That slash fraction button is only useful when you're doing things like that. 1/2, 1/3, 1/4. As soon as you got x's and other complicated stuff, don't go there. Keep it all like that. You will see every single problem I do will have the horizontal fraction bar because it does make it less clear what you're talking about if you use the other one. Okay? All right, number 13. Should I simplify what's inside before I deal with this, or should I deal with the exponent outside first and then simplify? Simplify first? Okay, so I'm going to ignore this -1 exponent and I'm going to deal with what's in here. In here, I have 2n to the 3rd on the top. On the bottom, I have a 2. I have an n to the -4th. Where should that end up going? Up. And then I have an n. Where should that go? Stay. So what's going to happen to the 2 over 2? That's going to cancel. On the top, I have n to the 7th, and on the bottom, I have n. So if I were to write that all out, which hopefully you're getting tired of doing and we're understanding the shortcut at this point, I end up with what? N to the 6th, because that 7th one cancels with the one on the bottom. And is it on the top or the bottom? Top, so I don't need to put the over 1. You okay now? Now I'm going to include the -1 exponent. So what does that give me? N to the -6th, which I have to write as what? Got to move it down so it's 1 over n to the 6th. So? I know this is kind of long notes, but I figured I'd err on the side of having too many examples than not enough examples and leaving you confused for your homework. Okay? All right, do you want to play around with number 14 for a minute before I go through it?
No.
Why don't you play around with it for a minute? See what you can do to simplify the bottom first. My hint would be start with those parentheses and then just keep simplifying from there. See, hopefully I have enough room to do this one. So doesn't this become 2 to the 4th m to the 8th? Right?
Yeah.
There. And then I have a 2m cubed over here. So this is what my denominator should look like. So it's really, what is 2 times 2 to the 4th?
16.
2 times 2 to the 4th is 32. I could also think about it as this is 2 to the 1st times 2 to the 4th, and that gives me 2 to the 5th, which is 32. So 2 to the 5th, and then I have 32. What's m to the 3rd and m to the 8th? M to the what? 8, 9, 10, 11. Okay, so let's look at this. I have 2 m to the -4th over, this is what I've simplified the bottom to be, 32 m to the 11th. Can 2 over 32 reduce?
16.
To what?
16.
To what? 1 over 16, right? By the way, did you know your calculator will reduce a fraction for you?
Yes.
You have a fraction button, it's right here. On the Casios, I think it's easier to see, but here, if I put 2 fraction button 32 and I hit enter, there's my reduced fraction. Okay, so that's going to become a 1, that's going to become a 16. So I have a 1 on top, I have a 16 on the bottom. Does the m to the negative 4th stay on the top?
No.
Move to the bottom, becomes positive. M to the 11th, stay on the bottom or move to the top?
Same.
Okay, so I think I'm ready for my final answer. 1 over 16, m to the what?
15.
15th. And that's what my final answer should look like. Okay. All right, reminder, we have a test coming up on Friday covering these exponent rules stuff as well as some of the radical stuff we did last week. All right? Happy studying.